Okay, so with scientific and standard notation is just a number that's written just like a regular number, whatever it's going to be. The big thing that they're going to have you do is work with scientific notation to work back and forth with the numbers. And I guess the basics on this one when you get down to scientific notation is it's going to be set up in a couple of different ways. You're going to have some number times 10 to a power. And when you set up with the number, for the number part that's here, the number has to be between has to be bigger than 1 but less than 10. So it's got to be a single digit number. So it's got to be 1 or bigger. So if you think about the number and the way it's set up, it can be as low as 1.0. It can be as high as 9.999. So it's got to be a single digit number for the first part of it there. All right, so as you're setting this part up for the scientific notation, that's basically the main thing it comes down to. And first thing they're going to do is just give you some problems where you've got a number and they're going to ask you to either 1, write it in scientific notation, or 2, take something out of scientific notation and write it back in standard form. And basically on this one, the way it's set up with the powers here, 2 different cases. If you have a negative power, you move the decimal to the left of the number. To convert it to standard form. Okay, so you've got some number times 10 to the power, and the number has to be between 1 and 10. So basically your cutoff line, if you had your number, would be something like that. Now actually it could be 1. 1's as low as it can go. 9.9999999 would be as high as it can go. Because if you go to 10, then you basically revert back to being that you have to move it back over and make it back to be a 1. But we'll get to some of that here in just a second. So if you have a negative power, you move the decimal to the left or in front of the number to convert it to standard form. And if the number is positive, or if the exponent is positive, then you move the decimal to the right. Okay. And basically the first half of 5.4, they'll give you some problems and just have you work back and forth on those, doing the positives and negatives. So here's basically what we do. They'll tell you to convert something to standard form. Or standard notation. Sorry, I think that's the way it's actually worded. All right, and then the objectives in section 5.4. This will be the very first problem, first objective that you would get there. Okay, so convert it to standard notation. You'll have a problem something like this, 8.722 times 10 to the 4th, maybe. And all that means is you'll take the number that you get here, and again, the exponent tells you how many times to move the decimal. Okay. And again, whether it's positive or negative tells you which way to move it. If it's positive, you're going to move to the right side. So all you do is you'll take the number you've got here and then just move it 1, 2, 3, 4 places. And if you move it beyond the numbers, you just go back and add in a 0. Okay, so for this one, the final answer would then be 87,220. Okay, and sometimes the numbers, you'll get something like this where you have to add a 0. Sometimes you may just move the number over a couple places and you may still have some decimal numbers behind it, but it doesn't matter. You just, whatever this number is that's in your power, you just move it that many times, and then whatever the number is you've got left over, that's all you have to do it. The only other thing that they do with standard notation is that they'll kind of reverse it, that they'll have you take a number that's in standard notation and then have you convert that back into standard form. Wait, no, I'm sorry. Said it backwards. Convert it to scientific notation. Sorry about that. Maybe something like this. Then we've got 5,140,000. Okay, so first thing this one's going to go back to is that if we're converting this into scientific notation, scroll back up real quick. The scientific notation part says you've got to have some number that's here, and that number has to be between 1 and 10. Which basically just means this, that whatever number they give to you, you're going to take the decimal and you're going to put it behind the first non-zero number. So you're going to make that 5.14, and then any other zeros behind it, we can just basically get rid of them because they're just extra numbers that's here. Times 10. And then all you have to do is that if we're going to put the decimal behind the first non-zero number, you basically just go back and count. Well, normally in the decimal number, in that number, your decimal would be here. And just count how many times you remove it. 1, 2, 3, 4, 5, 6 times. So then we're going to make it to the 6th power. Okay, so there's working with positive numbers where you wind up using either getting an answer with a positive exponent, or you have a positive exponent to use to convert, to move the decimal so that you get those. So positive numbers, basically you wind up with whole numbers when you get finished with them. If you have a negative exponent, let's go with this one first. Let's go to standard form first. And it can actually be 3.8 here. So we'll go with 1.96 times 10 to the negative 6th power. Okay. And as soon as you have a negative exponent here, then that basically means that you should get a decimal answer that's going to be less than 1. So negative exponent, we'll say results in an answer less than 1. Okay, so it's always going to be 0.0 something 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 when you go through those. So if you have 1.96 times 10 to the negative 6, you're still going to move this number 6 places, but instead of moving it to the right side, now you have to move it to the left side. So if you start with your same number that you have here with 1.96, now you're going to move it 6 times, but you're going to move it 6 times to the left. So it's 1, 2, 3, 4, 5, 6. And again, you go back and put zeros in the spot. And now for this one with the negative exponents, kind of the shortcut is that the first number will always move you in front, and pretty much you can just take one of these off. So if it's negative 6, you're going to move it 6 times, but the first number will always put it in front. So if it's to the 6th power, then that means you're going to have 5 zeros in front of it. If it was to the 10th power, you'd have 9 zeros in front of it. So that may be an easier way of doing that instead of, like the bunny hops and bunny hopping everything over. Just, if it's telling you to move it 6 places, 1 to get it in front, and then everything else will wind up being 0. So we've got 0.1, 2, 3, 4, 5, and then 196 for the number that would be in standard form. Okay, and then they'll turn right back around and say, okay, well now let's give you a number that's in standard form, standard notation, and then we'll convert it back into scientific notation. Okay, so let's go with 0.000334. Okay, and again, decimal always has to go behind the first non-zero number as you're working through the left of the number. So that would put you right here. So that's 3.334. And then at the same time, again, if you want to go back and count, that you got 1, 2, 3, 4 zeros here, which would put you to this point, and then moving it one more time, that would get you to the 5th power. So it would be 3.334 times 10 to the 5th power. Okay, so kind of along this one that, again, how many zeros you have, it'll be that many zeros plus one more number, so that, 4 zeros will get us to here, because that's the 4th zero, but we've got to go one more time so that the decimal winds up behind the 3 point. Okay, you want a few more? Yes, go ahead. Oh, I'm sorry. I forgot one thing there. My bad. There we go. Okay, sorry about that. Yeah. I was too busy looking at my loops and forgot about the negative there. Sorry about that. Yeah, that is a negative 5. Sorry. Yeah, I was counting my bunny hops and wasn't paying attention to my negative sign there. All right, is everybody okay with that one now? All right. Didn't mean to scare y'all. Okay, y'all need some more of those? Or I feel like it's okay? That's all right. Okay, so once they kind of get you used just to working the numbers back and forth, just changing the different things around, what they're going to do is they're going to do a couple of different things. They're going to ask you to multiply and divide scientific notation standard or scientific notation form numbers. And this would be objective 4 if we're going down the list here. So you'll have something like this where you get 4.3 times 10 to the 8th, and then times 2 times 10 to the 9th. Okay, and basically you got two parts for this one. All right, step 1, you're going to go ahead and multiply your standard numbers, the 4.3, the numbers that you have here. So we got 4.3 times 10 to the 8th and 2 times 10 to the 9th. So, you know, we're going to take the numbers that we have, the 4.3 and the 2, and just multiply those two things together. Second thing you'll do is if this is 10 to the 8th and 10 to the 9th, you're going to add the exponents. That's on the powers of 10. Okay, so for step 1, we'll do 4.3 times 2 for 8.6. And for your exponents, just 8 plus 9 for 17. Okay, and then for your answer, just go back and put those two things together, that now you've got the 8.6. It's always going to be times 10, because that's the part of the scientific notation that's always the same. And then whatever your power is that's here, well, that's the power that you get that goes there. Okay, now the good news is for this one, because the way it's set up here, if you're looking on the sheet, it says it's always basic. So when you get finished, the number that you have in front here should always be between 1 and 10. It's always going to be greater than 1, it's always going to be less than 10, so that when you get the answer, you don't have to worry about if this number was bigger than 10, you have to go back and start adjusting the numbers and moving some things around and doing some things with this one. They keep it just very basic. The numbers should stay between nothing less than 1 and nothing bigger than 10. So that the number's always just set and you're good to go here. Okay, and then the next thing they'll have you do, which again, they'll also keep it fairly basic here, is they're going to ask you to divide some numbers. And similar to the other one, just two things you're going to do. Step 1, you'll divide the numbers. And step 2, instead of adding the exponents together, since division is the opposite of multiplication, then you just do the opposite of addition. So in this case, then you'll subtract the exponents. Okay, so we'll go with 6 times 10 to the 9th, and then 3 times 10 to the 5th. Okay, so we'll go back and just do 6 divided by 3, which will be 2. And then for your exponents, it's 9 divided by 5 for 4. So your final answer becomes 2 times 10 to the 4th power.